Hello students, today in this class we are going to discuss still some concepts which are left in the electric dipole. We are going to discuss that one of the concepts we are discussing today is electric dipole in non-uniform electric field. So first, already in the previous class we learned, whenever you taken any charge, when it is kept in the electric field, what happens? It experiences a force. So according to the concept of force on a charge in the electric field is equal to force equal to EQ, because electric field definition is force acting per unit charge is called as electric field. So whenever the charge is kept in the electric field, it experiences a force, the force equal to EQ. There is only single charge. But in the case of dipole, okay, how many charges we have? Two charges. You can see the diagram here. I taken two charges. One is minus Q, second one is plus Q. Both are separated by small distance. The distance we are taking as delta x. Okay, so that is nothing but 2L, right? We can take it as. So whenever the two charges separated by small distance of delta x, that is called as dipole. Now this dipole we are placed in the electric field. You can see the electric field here. This is the way the electric field is there. If you see the different region points of the electric field, here the point starting point, these lines are spreaded more. Here they are a little bit closer, and here much closer. That means this is the electric field which is not uniform. Okay, uniform means what? Equal in magnitude, same in direction, then it is called uniform. But this electric field is not a uniform. It is a non-uniform electric field. That is only heading here. Okay, whenever the dipole is kept in the electric field, which type of electric field? Non-uniform electric field. It experiences a force. Now here, what way the forces are going to act on that dipole? Here negative charge is there, it experiences a force. Positive charge is there, it experiences a force. And according to concept, already you know that whenever you taken a positive charge, the force acting on the positive charge always in the direction of the electric field. And whenever you taken the negative charge, the force acting on the negative charge will be, that is away from the, that means away from the electric field. That means whenever you taken any negative charge, that negative charge will be moves in the direction of which direction? Away from the electric field. That means away from the electric field will go. Suppose if the electric field is going like this, the electric field is like this. In this case, this charge is going to move in this direction. Now in the case of positive charge, this is the direction of the positive in the direction of the electric field. So here our concept is negative is there, positive is there, both are going to be experienced as a force. So what direction the forces are experienced? If you see this positive charge will be experienced the force in the direction of the electric field. That means at this point, the direction of the electric field, what direction? That direction the force is going to act on the positive charge. Similarly, this negative charge also experience a force, but negative will be attracted by electric field. That's why what happens? It experiences a force in this direction. You can see the diagram. This is F plus, this is F minus, both are opposite in direction. This is one. Next, now we are calculating the force acting on this one in terms of the parameter of delta. So if you come across a case of in terms of parameter, you know that force equal to, that is nothing but E into Q is the concept here. Yes or no? E into Q. What is E here? Electric field, right? So whenever you come across a case of electric field, what way the electric field is acting here? So there are two forces. Here two forces are there. So that's why you have to take it as net force. You have to take it as net force. The net force is equal to, before taking, there are two forces, force due to positive minus force due to negative earthquake, because both are opposite in direction. Next, if you come across a case of electric field, this electric field is not a uniform, non-uniform. So at this point, you take it that means whenever you take on the starting point, the electric field, that means whenever the F minus is when it is facing the electric field, that means at that moment the electric field is, you take it as E. When this positive charge is experiencing the electric force, that moment the electric field you take it as E plus delta. So that means different places electric field is different. That's why taken as here E. If you taken that point as here, that will be E plus delta. That concept I applied in the case of this dipole. When the dipole is at this position of minus Q, so that means, sorry, when the electric field, if you are calculating at minus Q, that electric field is E. At plus Q, there is a small change in electric field because of non-uniform. That's why taken E plus delta. So if you write that force on the positive charge is equal to, what is the electric field? That is E plus delta. E is the electric field at positive charge, and charge of that one is Q, minus what is the force on the negative charge? Only electric field E, there is no plus E, into charge of that one is Q. If you solve this one, what you are going to get? Q net is equal to nothing but is equal to, this is EQ plus delta E into Q minus EQ you are going to get. So this plus EQ minus EQ get cancelled. So we are going to get Q into delta E here. So to get the expression in terms of dipole moment, because dipole having dipole moment, to express that one, what I'm doing is, this small change in electric field is existing between the small length delta x. Yes or no? Within this small region, the electric field is changing. That's why to write in the terms of delta x, multiply and divide with delta x. So delta x by delta x, if you multiply mathematically, nothing will happen. So in this case, I can write here. So Q into delta x into, now I can write that is delta E by delta x. Now in this case, what is Q? Charge. What is delta x? Length of the dipole. So charge into length of the dipole, what we can write? The charge into length of the dipole we can write as dipole moment. So this is nothing but P, the dipole moment P into, okay, that is I can write as delta E by delta x. So this is the one of the expression for force acting on the dipole in electric field. So that expression I can write in terms of short way as F is equal to nothing but, so dipole moment into force is a vector quantity, dipole moment into, that is delta E by delta x, that is dE by dx also we can write in terms of differential function. So this is the expression for force acting on the dipole in which variable electric field concept, that is what is the changing electric field is changing with respect to x. So in this case, force equal to dipole moment into rate of change of electric field with respect to distance. This is the concept of uniform, okay, force acting on the dipole in non-uniform electric field. Keep it in mind. Now the next concept is electric dipole in uniform electric field. Just before we discuss non-uniform, now in uniform electric field. So most important concept one is, as per the boards are competitive, CET competitive, or mains level questions can be asked on this one, torque on dipole concept. So here what we are taking here, consider one of the dipole. So first consider the uniform electric field. This is a uniform electric field taken. So whose magnitude is same at all places, that means magnitude is same, direction also same, that means it is called uniform electric field, which is oriented as you are looking here. Now in this, okay, electric field, what we are doing is we are trying to keep one of the dipole. We are trying to keep the one of the dipole as you are looking like this. This is the way I am keeping the dipole in this electric field. So the dipole contains positive charge as well as negative charge. So initially when I've taken, this is the positive charge, if you say, this is the negative charge. Practically, if you can come across the concept of this, any charge is placed in the electric field experiences a force. So here also the positive charge experiences a force, negative charge also experiences a force. Now what direction the positive charge experiences a force? Already we have to know the concept. In the direction of the electric field, the positive charge will experiences the force. Opposite direction of the electric field, the negative charge will be experiences a force. So according to the concept, this is the charge which is there that experiences a force due to this electric field in this direction. And this negative charge due to electric field, it experiences a force in this direction. So these are the direction of the forces due to electric field. So this force I can write as F equal to nothing but EQ. And this force F equal to EQ. Both the magnitudes are same. Both magnitudes are same. What are same here? Both magnitudes are same and directions are opposite. So both forces are opposite. Due to this one, what happens? Whatever the dipole you chosen here, that won't be stable here. That's why what happens? It will try to, okay, the positive charge try to move in the direction of the electric field. The negative charge try to move in the direction of the, okay, sorry, move in the opposite direction of the electric field. Due to that, what happens? This dipole will try to rotate. So rotation condition of any body is always due to concept of torque. So torque is nothing but double the, okay, force into perpendicular distance is called. That means force into perpendicular distance is creates a torque. The torque creates the rotation of any body. So here also the dipole, which is having length, that is 2L, from negative to positive, this dipole is going to be rotated about this center. If O is the center of this dipole, with respect to that center, this dipole is going to be rotated, and after rotation, the position of the dipole, okay, you can understand using the diagram. In this case, So the dipole at any position, okay, particular angle of that position. So in this case I can write now if the dipole is placed, okay, in the uniform electric field, you know that it is going to not stable. So first, according to already we discussed, this is the direction where it is experiencing the force F equal to EQ, and this is the direction where it experiences a force that is equal to F is equal to EQ on negative charge. Now this is the actual position, but due to this electric field, which electric field? Uniform electric field, this dipole is trying to rotate in the direction of the electric field. That's why it is trying to rotate. So when it is rotated, it makes certain angle with respect to field. That is, you take it as theta. So at that angular condition, so now it is trying to rotate. That's why we are saying it is under the concept of torque, because torque causes the rotation. So what point it is rotating? It is rotating about this center of this axis of the dipole. It is going to rotate. Now to calculate the concept of this one, first, according to torque, torque is nothing but concept is force into perpendicular distance between the, okay, two charges. Force into perpendicular distance. In this case, what is the perpendicular distance? To identify the perpendicular distance, you look at here, this is the one force, this is another force. This is one force, this is another force. Now you take the foot of perpendicular from here, this way I am taking the foot of perpendicular, this is foot of perpendicular, and that foot of perpendicular is the distance between the two charges in perpendicular direction, if you see this, right? So how much angle it is making? It is making an angle 90 degrees, perpendicular line. So the distance, the perpendicular length is not given, that length you take as x. So to calculate here, our concept to understand, now this dipole axis is making an angle theta with respect to field, so I can take it as here also theta here. So now if you come across the case of torque is equal to force, okay, force acting on the charge, both are same, that is nothing but I can write as force equal to EQ according to basic formula, electric field into charge of that one, into perpendicular distance. What is perpendicular distance? X value. We need to find the X value, but you don't know the X value in this. This is the perpendicular distance. To get that one, you know the 2L value. So here we are getting one triangle here, that is OAB. From this triangle OAB, I can write, you know the, okay, theta, X becomes opposite, 12 becomes hypotenuse. So according to the, okay, trigonometry, what I can write, that is sine theta is equal to nothing but opposite by hypotenuse. Opposite is x, hypotenuse is 2. So from this, what is the x value I can write? X value is equal to 2L into sine theta we can write. So substitute this x equal to L sine theta in the given expression. So in this, so I can write torque is equal to, that is EQ into, that is 2L sine theta we can write. Now in this case, the concept of Q into 2L, nothing but called as dipole moment, because it is a dipole, dipole always having moment. What is the direction of the dipole moment? Always from negative charge to positive charge. There is a concept already we learned in the previous. So I can write this one as P is the dipole moment. This Q into 2L is called dipole moment into electric field into sine theta, sine of the angle between. So according to vectors, when you are going to use the sine of the angle we are going to use when two vectors are multiplied using cross. So here torque is a vector quantity. Torque is a vector quantity. That's why we are getting the concept of P is sine theta. That means I can write P is one of the vector quantity. Cross E electric field is another vector quantity. So the cross product of dipole moment into electric field gives the torque concept. If you remove the, okay, cross, that means if you use the cross product, in this case the torque is equal to what I can write in terms of mod P mod E. Okay, and also we can write in terms of sine of the angle between them. In a particular direction, if you want to write that one, you can write that is n cap as a unit vector direction. So this is the concept of torque. Now we are going to discuss the cases of this torque. Okay, what factors the torque will be maximum, minimum, that we can discuss now. Just now we got the relation. Torque is equal to, that is nothing but PE sine theta is the relation we got in terms of magnitude. Now, if you come across case of conditions, cases, here we can discuss many cases. Case 1, if theta is equal to 0 degrees, what is the meaning of this 0 degrees? That means whenever you taken any dipole, this is the direction of the electric field, if you say, direction of the electric field. If we say if the dipole is in the direction of the electric field, the dipole moment is in the direction of the electric field like this. That means electric field is like this, having vector quantity. Dipole moment also vector quantity. So in this case, this is positive charge, this is negative charge of the dipole. If we say, okay, I'm taking the two dots here. Now in this case, the dipole and electric field both are in the same direction. Same direction means what is the angle between these two? 0 degrees. In this case, what is the torque acting on that one? To explain that one, torque is equal to, you take the magnitude of the P, magnitude of the E, and the sine of the angle, that is sine 0 degrees. So in this case, now already dipole, if it is placed in the direction of the electric field, it never experiences a torque because, okay, it experiences a force, but there is no perpendicular distance between the two forces. One force is acting forward direction, one force is acting backward direction. There is a pulling and pushing like that, but there is no perpendicular distance between the two forces because they are acting in the same line of, okay, dipole moment. That's why what happens, the force, okay, there is no rotational force is going to be generated here. So I can say simply torque is equal to 0, because according to mathematical also sine 0 is equal to 0, 0 and anything 0. This is one of the formula we can write. Next, go to the case 2. Next case, if we come across, if theta is equal to 90 degrees, theta is equal to 90 degrees means this is the direction of the electric field. If we say, now if you are keeping the dipole, clear, if you are keeping the dipole as you are looking like this, you keep the dipole like this as you are looking like this. In this case, this is positive charge, this is negative charge. So angle between these two is equal to 90 degrees. That means this is the direction of the dipole moment. If we say dipole moment always from negative to positive. So if the dipole moment is as you are looking like this, the dipole moment and electric field both are perpendicular to each other. In this case, now there is a perpendicular distance between the two forces. So that's why there is a torque will be takes place. Torque is equal to magnitude of the P, magnitude of the E, that means dipole moment magnitude and electric field magnitude into sine of the 90 degrees angle. What is sine 90? 1. So torque is equal to EP into E, we can write. So this is one of the, okay, torque, we can say maximum torque, we can say on this. So whenever the dipole is placed perpendicular to the electric field, it experiences a maximum torque. This is a concept of maximum torque. So if the torque is equal to 0, this is nothing but we are calling as minimum torque. Understand? So condition of minimum maximum you can understand. Next, case 3. What we can discuss in the case 3? Case 3. If theta is equal to 180 degrees, in this case, what is the torque? This is the direction of the electric field, if we say, as a vector. Now, if the dipole is placed opposite direction, opposite means what? So this is the way I am keeping the dipole in this direction. This is the dipole, if we say. So this is the direction of the electric field, if we say. Electric field is left to right, dipole moment is right to left. Both are opposite. In this case, the angle between these two will be how much? 180 degrees. So when they are 180 degrees, torque, how much? Torque is equal to P into E into sine 180. So what is sine 180 value? Sine 0, 0. Sine 180 also will be 0. So anyway, okay, whatever may be, the torque is going to be in the direction of the electric field. If the dipole is aligned in the direction of the electric field, in the same direction opposite, the torque acting on the point is always 0. What position it is maximum? At theta equal 90 degrees perpendicular condition, it is going to be becomes maximum. This is one of the important concepts. Now, torque is what base we are going to measure. Torque we are measuring in terms of basic formula is force into perpendicular distance, you know that, and Newton meter is one of the unit of this. But according to this concept, torque is equal to, that is PE sine theta, that is nothing but PE sine theta if you taken. So sine theta is the angle anyway, so I can write this one as a maximum torque as PE. So what is the unit of this torque? The unit of this torque we can write in terms of torque is equal to nothing but, what is P? Dipole moment. What is the units of dipole moment? Dipole moment P is equal to, already we discussed, Q into 2L. That is nothing but coulomb meter. And what is the electric field? Electric field is equal to force acting per unit charge, F by Q. Electric field is called F by Q. So if you write that one, if you want to write, that is Newton per, okay, coulomb we can write. So coulomb we can cancel. Again, we are going to get Newton meter is the unit of this. Similar one, we are going to get. you want to write in any other form, that you can understand when you complete the potential concept. So in the case of potential concept, this electric field also we are writing in terms of volt per meter. We can write volt per meter also one of the unit. Okay, I will discuss here. Then later you can verify that one. So torque is equal to, I can also write in terms of coulomb meter into, that is volt per meter. So we can cancel volt this. So torque is equal to, okay, coulomb volt we can write. This is also one of the unit we can express for this torque. Now we are going to discuss most important concepts in the competitive examinations that you have to keep it in mind after completion of this theory already done. So first point, if you look at, whenever the charge is placed in the non-uniform, charge means which one? Dipole charge. Okay, the dipole is placed in the uniform electric field. Now what happens in this case? It experiences force as well as torque both. So example already we discussed. So torque acting on the charge in the electric field. That means torque acting on the dipole. The electric field is equal to, what is that equation we got? Q is sin theta is the equation we got. In this case, the charge expressing the force, each charge is experiencing a force of F equal to how much? Q into A. So there are two concepts. Torque is there, force is there. But here the torque is causing the rotation. Now the force, what happens to the condition of the force? Whenever you taken the, okay, this is the line of electric field if you say, and this is the direction of the dipole moment if you say, this is the direction of the dipole moment if you say, that is P. So if both are separated by a certain angle, in this case, what is happens? This dipole always try to move in the direction of the electric field. So if this electric field is uniform, then what happens? There is a force acting on this, okay, positive charge, this negative charge. Already we discussed, this is positive, this is minus. So there is a two forces, that is, one is F plus, second one is F minus. Two forces are there. So in this case, what I want to discuss, this forces F plus and F minus, two forces are acting. So net force of the system is becomes equal to 0, because both are becomes equal and opposite along the same parallel line. So anti-parallel, it becomes anti-parallel. This is the way, this is the way, both are becomes anti-parallel. One is like this and second one is like this, both are anti-parallel. Anti-parallel means what is the net force? 0. But torque is not 0, because one is producing, okay, torque in one direction, other one is producing, both are producing the same direction of torque. So torque due to force into perpendicular distance, this is a perpendicular distance if you say F into R, this is a force into perpendicular distance F into R. Both are producing the torque in the same direction, so net torque will be added, so there is a net effect. So here we need to understand the concept here. So net force in the case of uniform electric field is equal to 0, that is the most important point, but torque is not 0. But in the case of non-uniform electric field, if you come across, in the case of uniform electric field, in this case, force, net force will not becomes equal to 0. And net torque also will not becomes equal to 0. So I can write this is in the case of which one? For non-uniform electric field concept. And F net is equal to 0 and torque is not equal to 0. This is the case we can discuss in the case of uniform electric field concept. That means when the dipole is placed in the uniform electric field, the dipole is placed in the non-uniform electric field concept.